Hiya. Today I'm going to talk to you about identities, okay, hyperbolic identities. Now, we've seen trigonometric identities already, and what you're going to see is that hyperbolic identities look fairly similar, okay. I'm going to start off with this one, okay. It says cos squared x minus sin squared x is the same as 1. It's already quite similar to the trigonometric counterpart, isn't it, where you've got cos squared x plus sin squared x equals 1. Now, this one is cos squared minus sin squared. Now, how do you prove something like that? Or how do you think you prove any hyperbolic identity? Maybe just pause the video, think about it for a couple of minutes. Done? Okay. Well, what you want to do is you want to pick a side, left-hand side, and then what you want to do is simplify that, okay, and try and get the other side, the right-hand side. Okay. Same with proving trigonometric identities. Okay. The method is kind of the same. So we're going to start with the left-hand side, and we're going to write out the definition of cos squared x and sin squared x. Okay. Now, cos x is this, 1/2 e to the x plus e to the negative x, okay? And sin x is this, half e to the x subtract e to the negative x, okay? But then cos squared is squared, and half squared is just going to be quarter, okay? So you can have that. Then the same with this, sin squared is going to be that squared, like that, okay? And then all we need to do is expand the brackets. Okay. I might not be able to fit it all on, so I'm going to start here. Is that okay? So 1/4, and then expand the brackets here, e to the 2x plus e to the negative 2x plus 2. Hopefully you're happy with that. Subtract e to the 2x, this is going to be quite similar, isn't it? Plus e to the negative 2x, and then subtract 2. Okay, that? Good. Can you see what we're going to be left with? Okay, I don't think you need to write down much, okay, but you should see it's opposite. That, subtract that will cancel, and then that, subtract that will cancel, and you're left with 2. We better write this down because I kind of asked you to prove it, no. So you have quarter times 2, so we're going to go 1/2, subtract, how shall I write it, as negative. There's something wrong with me today. Okay. Negative that times negative that is positive 1/2, okay, which is equal to 1. Okay, done. That's a proof of that. So hopefully you're happy with this one. Okay. Some of the others I'm just going to state to you, and some of them I might ask you to have a go at proving them. Okay. Right, so that's the first one. Okay. And let me just give you another one. Okay. Just at the top of my head, because I kind of like this one. The double, well, trigonometry is called the double angle formulae. I don't know what you call it here, to be honest. I don't know what you call it, okay? Because I did say they're not angles, are they? Okay. We've got sin 2x, okay? This one is the same as 2 sin x cos x. Okay. Well, there, I've stopped using the identity sign, haven't I? Probably quite early on, actually. Okay. But yeah, they're identities, so strictly speaking, you should have the identity symbol, okay? Yeah, that is another identity, okay? Can you think of any more? Well, I can. Okay, you've got cos 2x. Okay, that is the same as 2 cos squared x minus 1. You're probably thinking, how many of these are the same as trigonometric identities? Quite a few. Quite a few. Okay. Now, with the trigonometric counterparts, cos 2x, there were 3, weren't there? There's 2 cos squared x minus 1. The next one was 1 minus 2 sin squared x, wasn't it? Okay. This one though is 1 plus 2 sin squared x. Not quite the same. Not quite the same. Okay. Do you remember the other one? The trigonometric counterpart I'm talking about here. Let me just write it on the board. So the other one was cos, let's call it something different, theta. Cos 2 theta is cos squared theta minus sin squared theta. We can see it's not going to work the same with hyperbolic functions, is it? Because the cos squared minus sin squared is that one there. So, and 1 is not going to be equal to cos 2x. Okay. Now, any guesses where it is? Now I'm going to write it down. Cos squared, sorry, x. This is the trouble. This is what I get for writing down different letters. Cos squared x, and it's plus sin squared x. So it's kind of similar, isn't it? Okay, and there are other identities. I think in one of the first videos I mentioned tan x is sin x over cos x. Okay, another obvious one. Okay, Then there's identities for the a plus b. So you've got cosh a plus b. Okay. Do you remember what that is in trigonometry? When trigonometry, if you remember, that was which one was that? Is it cos, sine? I'm fairly certain of that. Yeah. It was cos, sine. So this one's cosh a, cosh b. Now, do you remember with trigonometry? It was then minus sine, wasn't it? This one isn't. It's plus shine a, shine b. Okay. Now there's another one here. Shine a plus b. This in trigonometry, it was sine, cos, sine, wasn't it? Okay. So that one is shine a, cosh b. In trigonometry, it was plus cos sine. Here, it's also plus cos sine, but cosh a, shine b. Okay. And let's go out another couple. Okay. I can't remember all of them. I've got a memory thing with the tan one, the tan 2a, yeah, and the tan a plus b. I never remember that. Okay, let's try and find out where that is. Here we are. No, that's not the one I wanted. No, not the identity I'm looking for. Let's just go to the back. Yeah, so bear with me. Sort of sing to yourself a little bit. Okay. Ah. Where are you? Where are you? You are killing me. No. So this has taken an inordinate amount of time. Maybe I should just... Oh, thank goodness I found it. Okay. Tanch a plus b. Okay. Well, I suppose if I'd have thought about it, I could have said, right, tanch a plus b, work it out while I try and find it. I didn't. Pause the video maybe and you work it out. Okay. Let me just write down here. Oh, I'm kneeling. Tanch a plus tanch b over 1 plus tanch a tanch b. Do you remember what the trigonometric version of it was? Yeah? It was similar to that, wasn't it? It was 1 minus tan a tan b. Yeah, okay. I'm just trying to see if I can find the one for tanch 2x. Oh, I've had a good idea. Why don't you work it out while I try and find it? Yeah. So the reason I can't find it is just because it's not really a useful one. That's why, to be honest. Yeah. Maybe it's an exercise question. Maybe that's why. No, where are you? So this is just taking too long, isn't it? I should really cut this bit out. It's like, yeah, great, yeah, yeah, yeah. Oh, God. Look good you are. Right, okay, so tanch 2x. I'm just going to say a and b are the same, because then that gives me 2a, okay? Can you see me down here? Really hope so. Okay, so that's going to be tanch a plus tanch a, that's 2 tanch a, I've used x, 2 tanch x, okay? Over 1, and then it's going to be plus tanch a, which is tanch squared, x. There you go. Who needs a book, really? Okay. Let's just check that they all fit on the board. Well, yes, sorry, they all fit on the board. Let's just check they all fit on the screen. Okay. Okay, yeah, there you go. Now, here's a really nice question. Okay. A lot of these are almost the same, one could say identical, to the trigonometric counterparts. Yeah, I mean, you can pick a few out. That one is the same in trigonometry, isn't it? That one's the same in trigonometry. I'll tell you what, let's tick the ones that are different. Okay. So this one here, that's different. Okay. What else was different? That was the same, that was the same. This one there is different. Okay, it's easy for me because I know what the wall is. Okay, that one's different. Okay, that one's different. Okay, that one's exactly the same. That one there, that one's different, and that one's different. Okay, what have they all got in common? Okay, because if you can find out what they've all got in common, then you've got a very handy way of converting a trigonometric identity to a hyperbolic identity. What I mean by that is, if you can memorise all the trigonometric identities, and then you apply this one single rule, then you can write down all the hyperbolic identities. Not got it? Let me give you a hint, okay? Look up Osborne's rule. Osborne's rule. I'm going to look up how to spell it. How do you spell Osborne's rule? Right, so it's O-S-B-O-R-N. So I can never remember if it's got an E on the end or not. Okay, Osborne's rule. O-S-B-O-R-N. Okay. So here we are. Did you look it up? And what did it say? Kind of a handy rule, isn't it? Okay, I don't even know who Osborne is. Okay, but it's a handy rule. Okay, there we go. Osborne's rule. Right, Osborne's rule states all the trigonometric identities match the hyperbolic identities, with the exception of when you've got sine squared x or a product of two sines together, in which case that term is negative. Examples, okay? Cos squared x plus sine squared x equals 1. The sine squared x term you change to negative. Okay, this one. Sine 2x is 2 sine x cos x. There's no sine squared and there's no product of two sines together. Okay, same with this one. This one, the 2 sine squared x, that's a sine squared x term, so you just make that negative. It was negative to begin with, it was 1 minus 2 sine squared x, so make it 1 plus 2 sine squared x. I'm hoping this makes sense. This one here used to be cos squared x minus sine squared x because of the sine squared term, make that positive. Okay, so you just multiply the sine squared term by a negative 1. Okay, the difficult ones to spot are this one here and another one. Okay, this is what we call a product of two sines, so it's an implied sine squared term, so you make that negative. That's why it's positive, that as opposed to the trigonometric subtract that. Okay, here you don't have a product of two sines, so we're fine. Here, what's going on here? Well, the tanh A tanh B, that is sine A sine B over cos A cos B, isn't it? So the numerators of the tan function, okay, that's a product of two sines. That's why that term, you make that negative. And obviously for that as well, the tanh squared is a sine squared. So I'm hoping that made perfect sense to you. Okay, that's all I'm going to talk about with identities. Okay, I won't say that they can be used to solve hyperbolic equations. Okay, and they can be used for some other important stuff like integration or differentiation as well. Okay. Hi, in this video I'm going to talk to you about identities, okay? Hyperbolic identities. In a similar way to trigonometric identities, you can see that the hyperbolic identities look kind of simple. What am I... Oh, for God's sake. Something's wrong with me today. Squared x, okay? That's what cos x is, that's what sine x is, okay? And when you square them, you're just going to have that. Okay, and then each one of these is going to be a quarter in it. Okay, so that's 1/4, and then that's 1/4 there. So yeah, that's all it is. Then you just expand the brackets and see what happens. Okay, let's expand the brackets. So we're going to have 1/4. Actually, I might not be able to fit all this on one line. So you know what I'm going to do? I'm going to just go in here. Okay, and I'm done with the identity sign. Hope you don't mind. Okay, so 1/4, and then this one is going to be e to the 2x plus e to the negative 2x plus 2. Happy with that? I'm so glad you said yes. And then this one is 1/4, and then this is going to be almost the same as that, isn't it? Okay, e to the 2x plus e to the negative 2x, and that's going to be subtract 2. Yeah? Okay, good. All right, then that's equal to minus